Okay, now we get to the dreaded long division. I started working through a few examples to see which ones I would share here, and immediately got into a little bit of trouble and thought this might actually show a reasonable case for using repeated subtraction. Okay. Okay, so you begin by going 18 into 9, doesn't go. Okay, so 18 into 96, and this is where you have to start really calling on some just know it knowledge. So 18 is nearly 20, and 96 is pretty close to 100. So maybe a good place to start might be 5 18s. So I'm just going to go off to the side here and calculate what that might be. This is the lattice method, by the way, and there is another video on it in the series on multiplication elsewhere. Alright, so 5 eighths are 40, 5 ones are 5, adding down the diagonals, 0 and 9. Oh, pretty good. Okay, so that probably works out quite well, but I used a lot of just know it estimating skills. So we say 5 times, and then we go 5 18s are 90, which we just worked out, and we subtract that number from the one above it, and we end up with a 6. Okay. We now draw down our other number, and we end up with 66. So 18 into 66. Okay, like we said before, 18 is nearly 20, so let's do some estimating. There's 3 lots of 20 in 66. That might be a good place to start. So 3 8s are 24, and 3 1s are 3. Add down the diagonals, and we get 54. Looks like we're going to be pretty close to our answer. And so we would then 3 18s are 54. Okay, and we would end up with 12. So 53 with a remainder of 12. Classic pencil and paper, long division, but you need to know some things, and estimating isn't a bad way to get to the probable right thing. Okay, let's try that same problem on another video using repeated subtraction.